Trigonometry. So, there's a good chance you've heard the word trigonometry. Is it frozen? It's okay. So there's a good chance you've heard the word trigonometry, but are unsure what it means mathematically. So, trigonometry is the study of sides and angles in triangles. And the first foundation of trigonometry to understand the relationship of angles and sides in triangles is understanding trigonometric ratios. There are 6 of them that connect to an angle and 2 sides in a triangle. And a ratio we want to think of as a fraction. So we're going to first talk about the definitions, and then we're going to practice coming up with these ratios. We're going to use these ratios to find missing sides and missing angles, and to solve right triangles, and to solve stories that connect us to triangles. So let's start here. These are the 6 names of trig ratios, full names. So, the first one is sine, the second one is cosine, tangent, and these 3 are the 3 main ones. These next 3 are reciprocals of the first 3. So the first main 3 are sine, cosine, and tangent. These are also 3, but they are secondary, and they're reciprocals of what we just did. And they are cosecant, secant, and cotangent. Now, we don't write down the full word. Instead, we use abbreviation for it. But because it's abbreviated, you're tempted to say it wrong. So when I see this right here, you still will say sine. Right? I know it's tempting, right, to say it differently. This is still sine. So what is that? Sine. And we know this is theta, which is an unknown angle. A trig name, these are all the trig names, have to go with an angle. They don't go by itself. So you'd never see this by itself without an angle connected to it. You'd either be an unknown angle, or you know an angle, like 30 degrees, 2 pi, whatever it is. But a trig name always is connected with an angle. Like here, this is cosine. Got it? So when you see this, you're going to say cosine theta. Not sin, not cos. Sine theta, cosine theta. Here, we're not at the beach. Tangent theta, right? Not tan. Here, not kiss. This is cosecant theta. Not sec, but secant theta. And we're doing this, we don't have to write the whole word every time, right? But when you see the abbreviation, you still have to say the word. Yes? Not cot. It would be cat if it was an A. Cot. So cotangent. So, our first introduction on the magic carpet with Aladdin, right? The whole new world. What is this? Sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. Don't worry, in the next 4 weeks, you will see it so often you won't have to do a flashcard. You'll know it. Got it? Okay, next. Listen. I need you to remember right triangles. What you know about right triangles is that one angle is 90, and that you use the Pythagorean theorem to find a missing side of a right triangle. That's what you know so far. Correct? Thank you. So, we're going to extend that right now. Do you know that there are names given to the sides of a right triangle? And the longest side is called the hippopotamus. Not hippopotamus? What's this called? The hippopotamus. What? The hippopotamus. What you want for Christmas. Did you know that? All you want is a hippopotamus. Nothing else will do. So, there you go. No, it's a hypotenuse. It's a hippopotamus. Hypotenuse. 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 You say hi? Say hypotenuse. Now, these smaller sides have a name too. There's no good reason for it, but they are called legs. So we have how many legs?
2.
And the longest side is called the? You already know that. It's just a review. Now, this is what you don't know yet. If you label one of the acute angles, not the right angle, but one of the acute angles, and you label it, we can then name the other sides differently. This will still be the hypotenuse, but the other sides we're going to call opposite and adjacent. So I want you to look at theta here, right? If I go across the triangle, we call that the opposite side. And if the side is right beside the angle, like touching it, we call it the adjacent. In English, ELA, if a store is adjacent to another store, what does that word mean for ELA? It means they're not across. Adjacent means they're beside each other. Okay? That's what it means. Big English word, right? So adjacent means they are beside each other. Yay. So, if the side is right there with the angle, it's called the adjacent. If you have to go across the triangle, it's called the opposite. And the longest side is the hypotenuse. Here we go. You ready? We're going to write down 6 definitions right now for each trig name that's brand new to you today. You ready? So, sine. The sine of the angle is equal to the opposite side divided by the hypotenuse. You ready? Cosine is equal to the adjacent side over the hypotenuse. I'm going to give you an awesome acronym to remember it in a second. Tangent is opposite over adjacent. And what you're going to write down to remember these 3, right? Because right now they're brand new. You need a little help to remember the definitions by memory. And this is what you're going to say. You're going to say, so, ka, toa. So, how are you going to remember? Sokotoa. Look at that, right? Now, you laugh, but when you have your quiz on Monday, guess what you should write down before you start your quiz? Right? You laugh, but right? We need help. So here we go. Cosecant is the reciprocal of sine. So it is hypotenuse over secant. There you go. I like that singing. Secant's the reciprocal of cosine. And cotangent, which will be the easiest one to remember, is the reciprocal of tangent, which is adjacent over opposite. Because cosecant, secant, and cotangent ratios are reciprocals, sine, cosine, and tangent ratios, they are called what type of functions? Reciprocal functions, and can be defined as follows. That a way to recognize reciprocal, you write down 1 over. So 1 over sine is a symbol for reciprocal. 1 over cosine is a symbol for reciprocal. 1 over tangent is a way to write down they are reciprocals. So when we go 1 over something, that means reciprocal. All right, we're going to get started. What we are eventually going to use today is also something called the Pythagorean theorem. So when we get there, you'll be, man, I can do that. And you get to use your calculator too. So that's not the issue. Got it? So let's start. Okay, number 1. I want to find the exact values of the 6 trig functions of theta. Unless you think you can do this without me, it's helpful on the video if you're not talking too much over me. So I want you to see and circle the angle with me. Can you circle it? I want you to label the side that's opposite of theta. And the side that's opposite of theta is right here. So we can write down the opposite side. And if you need to, so it doesn't look like a 0, you can say the opposite side is 12. What's the side beside the angle? We call that the adjacent side. And the adjacent side is 5. And then the longest side, obviously, is the hypotenuse, and that is 13. Now, we're going to use those numbers and the definitions that are above here. So, you are going to write down so, ka, toa. So, what's the definition of sine? What goes in the numerator? What goes in the numerator? The opposite side, which is 12. What goes in the denominator? The hypotenuse. Keep going. Fraction. How about cosine? What goes in the numerator? Adjacent. 5. And what goes in the denominator? Next. Tangent. What goes in the numerator? And what goes in the denominator? Oh, adjacent, which is, make sure I write it right, which is 5. Now, if you have these three, the ones on the right are just reciprocals. So cosecant's the reciprocal of sine, secant's the reciprocal of cosine, and cotangent's the reciprocal of tangent. You just did your first ever trigonometry question. All right, let's look at number 2. By the way, we're not going to do this every single question, that when you get more confident, you don't have to label it so directly like that. But at the beginning, it's good, right, to be slow and label it properly so you get it. Yes? All right, step number 1. You ready? Circle the angle. Where's theta? Can you identify which one is the opposite side? Which number? 4. And if you want on the triangle, you can label it O. Which side is the adjacent side?
8.
Sometimes, when the triangle is reorientated, right, when it's been rotated, you have to think, right? But what's the best way to know which is the hypotenuse? How do you know it? Do you see where the 90 is? The hypotenuse is always opposite of 90. So no matter where it is rotated, you can look for 90 and know the hypotenuse. Here we go. Next, you don't have to write it down again and again if it's right there, right? So, ka, toa. All right, go. Write down what sine is. You do it. Now, a couple things. We cannot leave a square root in the denominator. So if you have a square root, you have to change it to a rational number. Now, 4 divided by 4 is 1. And what would I multiply top and bottom so that we don't have a root 5 on the bottom? So it's just root 5 over 5. Usually in trigonometry, if you have a square root in the bottom, it's simple to undo it. It's not one of the more complicated ones. Cosine. That is 8 over 4 root 5. I can't leave it that way. So, 4 goes into 8 how many times? And then what do I multiply top and bottom times? So 2 times root 5. And what's root 5? Root 5 is just 5, and you have it. Tangent is opposite over adjacent. So 4 over 8 is also the same as, but we don't have a square root. Now, when I do the reciprocal, don't go from your final answer, because if you flip that, guess what you have on the bottom again? Root 5. I don't want that. So go to the first fraction. Remember the first one you had before you changed it? So flip that one and you get root 5 over 1, or just root 5. Do you see how I made a choice? That I went to the one that doesn't give me a square root on the bottom when I flip it. So again, which one am I going to flip? It's going to be root 5 over 2. Remember we crossed these out? And then lastly, 1/2 is just 2 over 1, which is 2. Yay? All right, number 3. Before you think that we got it already, let's see if we really got it. I'm listening.
For the final answer, do they have to be simplified?
It's good practice. Yes. Here we go. Number 3. Especially if it's not painful. That is not painful to reduce down. Number 3. Hey, can you label and tell me each side? So what did I tell you to do first? Circle the angle. Hey, what's the opposite side? Blank. What? So, most of the time, you won't be given all 3 sides of a right triangle. You know why? Because you have the ability to find the missing side. So, what we're going to do is, we're going to label the missing side what? Do you know how to find x? Hey, it's right there. Do you know how to solve for x and find the missing length? We are going to use what theorem? And here it is. The Pythagorean theorem is, you take a leg, any leg, and what do? So let's say x. Is that a leg? What's the other leg? Does order matter? No. But it does matter that the legs are together, and the hypotenuse has to be by itself. And what's the hypotenuse? Now we're going to solve that. Now, if you're good with your calculator, because I said you're allowed to use it, how would you get x by itself in one step? You would, I'm not using my calculator yet. I'm going to do what? Subtract 20 squared, and then what do? See how I did that in one step, and I only have to use my calculator once, and not keep going back to it. What's the square root of 29 squared? Take away 20 squared. And you are going to learn how to get to that line right away. You're not going to write down a squared plus b squared equals c squared. You're not going to think the Pythagorean theorem is just the alphabet. You know it's leg squared plus leg squared equals hypotenuse squared. And you can rearrange it because you are now in upper level math. You are not in 7th and 8th grade where you saw it the first time. Yes? All right, type it in your calculator. The square root of 29 squared, subtract 20 squared. You can do it. Here, I'll show you how easy it is. Do you know where the square root button is? Blue button. It's right above the x. And then we type in 29 squared. That's like that. Can you type in 29 squared? Subtract. What is it? 20 squared. The only thing you have to do is close the parentheses at the end and then enter. We don't want to go diamond enter. We don't want to have a decimal answer here and round it. That's not working for my triangles. It has to be exact. So if it's a good exact answer, great. If it's like 5 root 2, you write down 5 root 2, and we're not going to have like 2.881 on our triangle. Okay? Now in this case, it's good, isn't it? So what is the length of that triangle? 21. So what did we just find out? We found out the opposite side is 21. What's the adjacent side? 20 and the hypotenuse. And now we're ready to go. So here we go. Can you find the primary trig ratios? Sine, cosine, and tangent. Those are our 3 primary ones. And the other ones are reciprocal. So what's sine again? Hey, I don't see SOHCAHTOA. So I'll write it down again. SOHCAHTOA. You're in luck. There's an awesome math song that goes with it. That's right. We'll make a choir. No, I'll show you the video. Here we go. Sine. is opposite. So it's 21 over 29. Cosine's adjacent, so it's 20 over 29. There's nothing that can be reduced down here. Tangent is opposite over adjacent, which is 21 over 20. And then it's just the reciprocals, right? So just write down the reciprocals. So keep going. I need you to find the missing side here. So let's go. So I'm missing a side, correct? Which side am I missing of that triangle? Hypotenuse or the hippopotamus? So you are going to learn this. You ready? In one step, how would you find the hypotenuse? You ready? We're not going to write down a squared plus b squared equals c squared. We're going to be really big about this. We're going to write down square root. Because you know c squared, what are you going to have to do eventually? Square root. And then what goes inside it? What's one leg? And what's the other one? And what do you do with the two legs? You add them. There it is. One step. Put in your calculator. At first, it's going to be awkward. But as you practice, you'll recognize, am I adding or am I subtracting? And it's the square root, and you'll see the structure of it. So, square root. Let me show it to you on here. How do I type that in? So start with square root, and then it's another parentheses. See how I started with two parentheses? And it's going to be 6 root 3. Close it, and then square it, plus 6 squared. It's a little bit more challenging. See how I have to use a bunch of parentheses to make sure it's typed in correctly? So when you have an irrational number that you're typing in, it's a little bit more challenging. Do not go diamond enter. Just enter. And what's the correct answer? Is, what's the missing side? Make sure, look carefully. Can you look at the bottom line and how you type it in correctly? Chris, you need to learn how to type it in correctly. So I need you to look at the bottom line and see the parentheses I used, and you have to do it. You can't do it your own way. You can't do it the way I know what I mean. The calculator should understand what I mean. So like whatever, you have to type it in correctly for it to get the right answer. So it needs those parentheses to be typed in correctly. So the missing side is? The missing side is 12. Here we go. Sine. Now, circle the angle. Which side is opposite? So it's 6 root 3 over 12. And 6 goes into 12 twice. Cosine. Which one's adjacent? So adjacent over hypotenuse, which is 1/2. Tangent. That's opposite over adjacent. The 6's divide out, and it's just root 3. And then the reciprocals. So I'm not going to go from root 3 over 2. I'm going to go before. And if I do the reciprocal, I guess I could do this one. So 2 over root 3, what do I have to multiply top and bottom times? So 2 root 3 over 3. 2 over 1 is just 2. And this one is 1 over root 3. So 1 over root 3, if you multiply top and bottom by root 3, is root 3 over 3. All right, turn the page. All right, number 5. Now, in number 5, you're not given a right triangle. Instead, you're given one of the trig ratios. So right now, I already know what's tangent theta. 7 over, and cotangent is 24 over 7. It's given. I don't need to do anything. But to find the other ones that are missing, what I have to do is draw my own right triangle. So I'm going to draw a right triangle. Now, you decide how you want to orientate your right triangle. You'll get the same answer no matter how you orientate it. Do you know what I mean? So that's how I draw it, the right triangle. If you draw it a different way, it's okay. Label the right angle, and then in one of the corners, it doesn't matter which corner, in one of the corners, you're going to put in theta. Again, it does not matter which corner, because wherever you put it, the opposite side will go with it. So, tangent by definition is opposite over adjacent. So how big is the opposite side and the adjacent side? What don't I know that I need to find? To find the hypotenuse, it is the square root of 24 squared plus 7 squared. Use your calculator. To find the hypotenuse, it is the square root of, in order doesn't matter there. It could be 7 squared plus 24 squared. In one step, type it in your calculator. This is a Pythagorean triplet. Do you know what that means? A Pythagorean triplet means all three sides are rational numbers, right? That's a triplet. So that means this answer won't be irrational. Do you know what the hypotenuse is? Yeah. So 7, 24, and 25 is a triplet. All right, now we can fill in. Tell me what's missing. So, what sign? Opposite over hypotenuse. What's cosine? Adjacent over hypotenuse. And then the reciprocals, and it's over. All right, try number 6. If you are given one of the 6, so you know one of the 6, can you use that to find all the ones that are missing? You ready? Go. So what are you given in number 6? Cosecant. Hey, I'm just going to fill that in. 37 over 12. What else do I know right away? Sine. What sine? 12 over. See how we know 2 right away? Now what are we going to do? Is we're going to draw a right triangle. And in that right triangle, label 90, and then put theta in one of the corners. The definition of cosecant is the reciprocal of sine, which is hypotenuse over opposite. So we know the hypotenuse is 37, and the opposite side is 12. What's missing is the adjacent side. We're going to use the Pythagorean theorem. It is the square root of 37 squared subtract 12 squared. So when you're looking for a leg, you're not adding, you are subtracting. If you're looking for the hypotenuse, you are adding. See the structure? In one step, and we don't take 5 steps, we don't take 3 minutes, we take 20 seconds and you find the missing side. Is this a triplet or is it irrational? It's a triplet, isn't it? What answer do you get when you did that? Did you get 35? So when all 3 sides are rational, we call that a Pythagorean triplet. Now we can fill in. What's the adjacent side? We just found it. 35 over the hypotenuse, which is 37. How about secant? That's the reciprocal. Tangent. What is that? Opposite over adjacent. And then the reciprocal. All right, number 7. I need to give you a chance. So, number 7. All the way. Let's see what you can do. I'm going to walk around and see. On the video, you can fast forward. Is it too dark? Let me turn on light. I just need one person to make sure that that person's happy. Here we go. Is that better? As you get older, first thing that goes, your ability to see with like a little bit of light. You know that no one can see in the dark, not even cats? That cats still need light, they just don't need a lot of light. Do you know that? So if you put a cat in a sealed box, which you should never do, the cat cannot see if there's not even, it just, doesn't need a lot of light. Okay? So they say as you get older, that's the first thing that becomes difficult. Is that you need more and more light to see. Do you ever have like someone, parents, grandparents, that say, turn on light when you read? You get that? That's because they can't see. So they think you can't see. Oh, that's bad lighting. Ever hear that one? You can't see. Just tell them, they're getting old. You can still have your cat eyes, right? That just need a little bit of light. Are you trying your best? So number one is label it. So cosine is 5/9. Did you put it right in the box? So which other one do you know right away? Secant, right? Done. Did you draw a right triangle? Did you label it? And then did you use your calculator, right, to support you, to find the missing side? So I know it's 5/9 and 9/5. You did that, right? You drew a right triangle. And you know it's 5 and 9. I need to find this missing side. So to find the missing side, it's 9 squared, subtract 5 squared, and use your calculator. Again, do not go diamond enter. I don't want the decimal answer. What is it exactly in your calculator? Did you get that answer exactly? 4√2? Not diamond enter, just enter, right? I don't need a decimal. The square root of 9 squared, take away 5 squared. Is it that? Oh, I did it wrong. What is it?
I got 2 square root of 13.
I was looking at the wrong question. 2 and the square root of? There we go. Did that make it better?
Yes.
There you go. I can tell on your faces when I did something. So, 2√14. All right, now we're ready. So, sine is opposite over hypotenuse. Do I need to change that ratio at all? 2√14/9? No. But when I do the reciprocal, I have to. So what do I multiply top and bottom times for the reciprocal? Just √14, not 2√14, just √14. So it's 9√14. And then on the bottom, what's √14 times √14? 14 times 2. I know it feels like it, but you can't reduce it down. There's no number that goes into both to reduce it down. The √14 doesn't go with 28. All right, tangent. This will be much easier. Opposite over adjacent. And then again, when you do the reciprocal, what are you going to multiply top and bottom times? Just root. And you already did that, right? So it's 5√14 over, we just did it, 28. All right, one more. Then we're going to talk about special right triangles. Did you know there are 2 triangles that are special? They are big in trigonometry, the 2 special right triangles. All right, we'll get there. One more. Hey, let's go. Hey, for number 8, I don't see a fraction. What should you do? So, if secant is 4, then what's cosine? 1/4, and then you have 2 numbers for your triangle, right? And you're not looking at anything. I don't know, there's only one side, it's 4. So, you already know 2 answers in your box, correct? Then, can you draw a right triangle? Are you training your brain to find the missing side of a right triangle quickly? One step with your calculator. If you are subtracting and you get an error message, you didn't put the bigger number first. Right? Like, if you put the smaller number first and you try to take the square root, it'll be a negative answer and imaginary, right? You need to make sure the hypotenuse is first. All right. So I know secant and I know cosine, yes? I draw a right triangle. I label it. I already know the hypotenuse and the adjacent side. And then it's the square root of 4 squared minus 1 squared. You might even be this good. Do you know that 4 squared is what? 16, 1 squared. So you could actually square it in your head. In your head, what's 16 take away 1? See how you can do that without a calculator in one step? Because you are comfortable with the Pythagorean theorem, you don't have to stay in 7th grade. Right? You can advance and be quick about doing that. You don't think you did this in 7th grade? Pythagorean theorem? 8th grade. All right. Your 7th grade math teacher should be ashamed. So, opposite. Oh, Michael, you'll say that about me when you're like way older and like, wow, right? Got through college. So, reciprocal. Now, I can't leave root 15 in the denominator. What did I just do? Silliness. Root 15 over 4. Now, that's good. So, 4 root 15 over what? 15. I just started to doubt myself. Tangent. Opposite. Root 15 over 1 is just root 15. And then the reciprocal, when I multiply by root 15, is root 15 over 15. All right. Last part of the lesson. Do you know that there are 2 special right triangles? Who has thought and have been taught 2 special right triangles in their life ever? Anyone? Or is this brand new Aladdin stuff? This is all Aladdin, right? Here we go. There are 2 special right triangles. This is brand new. So you're going to have to give yourself time and study to make sure you know them. This you have to memorize. There are 2 special right triangles, and what makes them special is that I know the angles and the sides on the outside both at the same time. One is called a 30, 60, 90. And the ratio of the sides are, circle 30, and you're going to count. Across from 30 is, because you need to know how to memorize this. Across from 30 is 1, the hypotenuse is 2, and the adjacent side is 3, but it is root 3. It's 1, 2, 3, and that 3 is root 3. You have to memorize that, because there's a part of trigonometry you're not allowed to use your calculator. That you have to know something by memory. This is big. So what did I do to do it? So circle the 30. Opposite is 1, 2, 3. Got it? Root 3. What's the other special right triangle? It's called a 45, 45, 90. Now in a 45, 45, 90, this is actually an isosceles triangle. What does that mean? 2 sides are the same. 1, 1. What's the next number after 1? And it's root 2. So, however you want to memorize, these you have to memorize. 30, 60, 90. Circle the 30. 1, 2, 3, root 3. Isosceles. The legs are 1 and the hypotenuse is 2, but a root 2. Now, where do I use these? Is if I want to know exact values of these trig ratios without a calculator. So, for instance, what's the value of sine at 30 degrees? Not theta, but an actual angle that you know. Well, the definition of sine is opposite over. So the answer for sine 30 is 1/2. And we're going to learn how to also use our calculator. If we typed in sine 30 degrees, the answer would be 1/2. What's sine of 45? What triangle would I go to? The second one. And either one would be the same answer. What's opposite over hypotenuse? 1 over. And then how do I make that correct? What do I multiply top and bottom times? How about 60 for sine? Do you see where 60 is? What's opposite? So it's root 3 over 2. Cosine 30. What's the definition? Do you need to write the definitions on top to remember what the definitions are? What's adjacent of 30 degrees? Do you see 30? What's adjacent? Root, no negatives. Root 3, and then what's the hypotenuse? Cosine 45. Well, guess what? Sine and cosine are exactly the same because the legs are exactly the same, so it's root 2 over 2. Cosine of 60. What's cosine again? So, can you see where 60 degrees is? What's adjacent to that? So it's 1 over hypotenuse, right? Tangent. What's tangent for 30 degrees? What's opposite? 1. What's adjacent? And then how do you make that look right? Root 3 over 3. 45. This is the easiest one. Look at 45. Opposite over adjacent. 1 over 1. 60. Go back to the first triangle. Tangent. What is opposite of 60? Root 3 over, or just. Now, how will I fill in the rest of the table? Reciprocal. What's the reciprocal of 1/2? 2. What's the reciprocal of root 3 over 2? And then multiply by root 3, top and bottom. What's the reciprocal of 1 over root 3? Or just root 3? Here. What's the reciprocal of root 2 over 1? What's the reciprocal of root 2 over 1? What's the reciprocal of 1 over 1? Right? And if you got to go back later in the video, you can. The reciprocal of root 3 over 2, and then multiply by root 3. The reciprocal of 1 over 2, and the reciprocal of root 3. So, I'm going to go back again. You filled it out. That these are two special right triangles you need to have memorized. 30, 60, 90, and 45, 45, 90. Hey, do you recognize some numbers repeated in the table? Yeah. Like, for instance, the value of sine at 30 is what? 1/2. What's cosine at 60? Do you see how they are the same answer? 30 and 60 are called complementary. Have you ever heard that? That's two angles that add up to, for trig ratios, if the angles add up to 90, their answers are the same. Like, do you see root 3 over 2 and root 3 over 2? Or 45 and 45? Those are all what? Complementary, right? They add up to 90. And their answers are the same. Big. Do you feel like you went on the magic carpet? Something brand new, you saw the sunset, the sun went down, the whole bit, right? And you've never seen the world like this before, have you? So, you have to work, study, be patient, and we're going to keep going back to it, okay? All right, Mr. G Math, over and